All right, here we go. All right, I'm gonna share my screen and then here we go. All right, number one, I'll do the 10 push-ups after everything. So maybe I might have to like 40 or 50, so we'll see how it goes. All right, so we'll see. Okay, I'm all nervous now. Okay, so all right, we'll figure it out. All right. Okay, for the following equation, y equals 2x squared minus 6x, convert the following equation in vertex form, graph the equation, find the solutions of the equation, and then the axis of symmetry. All right, so this is a good problem just to bring everything together. All right, so let's convert the equation in vertex form. Remember, this was a little bit of controversial because 2x squared minus 6x plus 5. Again, Mr. Che likes to subtract the 5 first. I know a lot of people don't like to do that, but I like to do that. So it's y minus 5 is equal to 2x squared minus 6x. Oh, dang it. Okay. And then y minus 5 is equal to, you factor out, it's x squared minus 3x. Remember, you don't factor out the x, right? Because we're completing the square. Oh, God, I use a fraction. All right. So 3 divided by 2 is 1.5. 1.5 to the second power is 2.25, right? So it's plus 2.25, right? And then if we add 2.25 to this side, we're multiplying it by this. So multiply it by 2 and it's 4.5. So we're adding 4.5 to the other side. All right. So what this gets is y minus, let's just say it 1/2 equals 2, and then x minus is 1.5, right? Squared. All right. So our vertex form in this case is going to be that y minus k is equal to a and then x minus h squared. All right. You could also add the 1/2 to the other side and then use the other vertex form. But again, just remember that k is a little flexible. It could go both ways. Okay. Remember the vertex form was this. This is how we introduced it. Okay. So either way you go is fine. Okay. As long as you acknowledge what the vertex is. So our vertex is what? 1.5, right? And 1/2, right? And we've converted this to vertex form. So this is vertex form right here. All right. Graph the equation. Let's graph the equation here. So if we graph, right, it's going to be 1.5, 1, 2.5, and then 1. And then you're going to just choose 1 and 2, right? In terms of the table right here. So if you plug it in, you can choose 1 and 2, and then you're going to choose 0 and 3. You guys remember all that? So y is equal to 2x squared minus 6x plus 5. So 2 times 1 squared minus 6 times 1 plus 5. 1 squared is 1, times 2 is 2, minus 6 plus 5. -4 plus 5 would be 1. So remember, the y value for 1 is going to be the same as the y value of 2. And then if we plug in 0, it's going to be 5. And so if we plug in 3, it's also going to be 5. So 2, 3, 4, and 5. And 5 here. So this is your graph here. Find the solutions to the equation. Find a solution to the equation. Are there any solutions? No, why not? Good job. It doesn't cross the x-axis, so axis of no solution. And the axis of symmetry is what? This line down the middle. So what's the equation of this line? X is equal to what? 1/2. Okay. No, it's a 1/2. Thank you. 1/2. All right. Thank you. All right. We good? All right. Any questions on that? All right. Number 2. All right. See, it's a lot easier than you think, right? I mean, I think a lot of you guys were freaking out. The sub kind of was saying that you guys were talkative and didn't know what to do and stuff like that, being all dramatic and everything like that. Relax. All right. You guys are fine. Okay. So just, you guys don't go crazy on me. Okay. It's just one person that has to go be dramatic, and then it's like, oh, and it's like, relax, just relax. So y is equal to 3, and then x minus 4 plus 7, right?
It's in the vertex form. But it's already
Yeah, sorry. So it should be in standard form here. Thank you. So what? X times x is what? X squared, we're a FOIL, minus 4x plus 16 plus 7. There's a little bit of a delay in the Zoom, so. All right, then combined like terms will be 3, and then x squared minus 8x plus 16 plus 7. And then distribute. So it'll be what? 3x squared minus 24x plus 48 plus 7. So the answer is y is equal to 3x squared minus 24x plus 55. All right. You could factor or use a quadratic formula. This is going to be a tough one here. Let's try, I don't know. Should we try the quadratic formula? Well, actually, we should graph first, right? Let's graph first. I'm looking ahead right now to the solutions. I'm kind of dreading it, but at the same time, there might not be solutions on this one. Right? So the vertex is what? 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. There are no solutions on this one because the parabola is going to go up. So I'm going to choose on the table, I'm going to choose which numbers here? 3 and 5. And then 2 and 2 and 6. Right? So let's use vertex form because I think this is a little bit easier on this one. 3 and then x minus 4 squared plus 7. So y is equal to 3 times 3 minus 4 squared plus 7. 3 minus 4 is -1. -1 squared is 1. 1 times 3 is 3. 3 plus 7 is 10. So we're at 1, 2, 3, 4, 7, 8, 9, 10. And then 5 would be 10. And then y is equal to 3 and then 2 minus 4 squared plus 7. This is -2, 4. -2 squared is 4. 4 times 3 is 12. 12 would be 19. So I'm just going to go all the way up here. And it should look something like this. And again, there's no solution, all right, because it doesn't hit the x-axis. And remember, if it does hit the x-axis, you need to factor or you need to do the quadratic formula to find that, right? And then the axis of symmetry is what? X equals 4. Okay. Standard form. Make sure you put no solution. And can you guys get in the habit of circling your answers? It's kind of hard. Sometimes it's kind of hard to read. Just circle your answers, and I think we could. You'll be okay. All right. We good? All right. All right. Describe and graph. Okay. First of all, we describe it's an absolute value. It is going to be reflected over what? Yeah, y-axis. You factor it out. If you factor out the y, so y equals -2 and then x plus 3 plus 6. Which way is it shifting? Shift is 3 to the left, right? Because this plus is really a minus, right? And then what? Up 6. It's a horizontal what? To stretch or shrink? Shrink by 1/2. Okay. All right. Are we good? That's good. What you really want to do is just, in this case, you just want to just graph y is equal to 2. Oh, sorry. Y is equal to absolute value of 2x. And then from that point on, you can reflect, right? And then you could kind of shift it over from there. I think that's a lot easier than plugging in numbers from that point. Again, you can do whatever you want, but if you just graph this, then you can just shift it 3 to the left and up 6, right? So let's do a few problems here. So we know that it's going to be at -3. Oh, well, let's just do this first. So this is 0, 0, right? And then let's do 1. If I plug in 1 for x, the y is going to be 2.
Mr. Shane,
What?
I think you.
Which one?
The y x as the value -2 is supposed to be x or -2x or -2. Wait, no, never mind.
So I purposely left the negatives out, okay, because I know we're gonna reflect, right? Okay, over the y-axis. So that's what I did. But why? What's going on? Wait, why are you freaking out? -6 plus 3. Oh, no. All right, so I'm dyslexic. All right, so this is 3. So this is 3, and then this is 3 right here. Yeah. All right. That's not a true mistake. That's like that's an ADD mistake right there. So yeah, that's an ADHD mistake. So that's okay. So are we good? I'll give you 10 right there. That's deserving. Okay. Any other questions? Don't freak out. Are we good? You guys you guys are freaking out because you guys wanted me to do this push-ups. So all right. Okay. Are we good? Everything good? So we are the 3 is right because I took out the -2, right? You see that? So from here, like this point right here, I took out the -2 here, and then it's x plus 3. You guys see that? All right. Cool. All right. Any questions? Don't freak me out. Very good. I'm scared now. I'm all shaky. You know, because I can't do if I have to go to 20, I'm gonna shake. I'll be all shaky. So, are we good? All right. So 1, 2. All right. And then if I go 2, what happens? This is 4, right? And then if I go -1, what happens with -1? It's still 2, right? And if I go -2, that's still 4. Right? So 0, 0, 1, 2, 2, 4. And then this is it, right? That's this. Right? So that's what this is going to do. Reflect over the y-axis. It's pretty much what I'm doing is if I reflect over the y-axis, it's pretty much the same, right? Because everything's just getting switched, right? So the x values, the negative x values turn positive and the positive turn negative. So it's the same. All right. So now all I'm doing is what? I'm shifting 3 to the left. So this is the new one. 3 to the left, 1, 2, 3. And so that's shifting 3 to the left. And then I'm gonna go up 6. So this is 1, 2, 3, 4. And that's that. Are we good? Do this correctly? Hopefully I did. Right. Yeah, I mean, I already accounted the horizontal shrink by leaving the 2x inside that absolute value. Okay. Good. Yeah. So, oh my God, I'm sorry. I really deserve it. Yeah, by 3. I should shift up by 3. My bad. Thank you. So sorry, yes, yeah. Okay, well, keep that in mind here. Yeah, good, good. Yeah, what's going on?
When we're giving the two X from, and I don't know where the original equation's coming from, and.
Okay.
You're shifting, and it's just.
Yes, that's what's fun about this, but that's why I get kind of crazy with this too, right? So, okay, let's start all over with this. Okay, so not start all over, but let's try to. We have y is equal to the absolute value of -2, and then we have this right here, right? We know this is +3, right? I keep putting 6. This is do you understand that part?
Yes.
Okay, does everybody understand that? Because I took out the -2, and we're good there, right? Okay, so now what I did was I graphed this first, because I knew that if I graph this, right, the y equals absolute value of 2x, it's so much easier to graph this from a table, right? Okay, so if I graph this, then we're good, right? So, well, we could do -2x if you want. Okay, but remember that the negative is reflected over the y-axis. So as long as I just keep this portion here, okay, we can reflect over the y-axis. You can keep it -2 if you want. If you want to do that, that's fine, right? But just know that, like if you, I don't like working with negatives because I tend to make a mistake. That's why I was just like, let's just keep the 2x, and then once you can reflect it, and then shift it left 3 and up, left 3 up 3, yeah. All right, so that's where I got that from. Okay, any questions on that? Okay, we good? That's from here. That's 2x is related to this. But again, I'm not accounting the negative, because I know that if once I get it on the table, I just have to reflect it over the y-axis, and I'm good. We did that right here. Mhm. Because that's the parent, that would be our kind of our parent function kind of thing.
Why is there X like this? Just take it out, like, it's -2 for X equals to Y, and then 2X in the after that.
So the 2x, what's the relationship between this and this? What's the relationship between these two? What if I did these two, what would the relationship be on that one? What's the, oh, sorry, not relationship, what's the difference? I would what? I would shift 2 to the left, that's it, right? So the difference between this and this is I just shift 2 to the left. Does that make sense? So that's why I just did this part right here. Again, you guys could just plug in numbers, that's fine. Okay, I mean, you could, so what you could do is y is equal to -2. If you did this, that's fine too. And then just plug in numbers from there, that's fine too. Okay, but I think I feel like this is easier just because you're dealing with less numbers. I could get that point, and all I have to do is just shift things and then reflect things, and I think that's a lot easier. Okay, but it's up to you. Yes, Karen. So that's what the 2 does, right? The 2 tells you the horizontal shrink, right? So by graphing this, I already account for the horizontal shrink. All right. Cool. Getting this? We're good?
So the black one is the horizontal shrink.
The black already, yes, the black graph already accounted for the horizontal shrink, yes. Okay. We good? Yeah.
One of the ways to look at your parent function is you see what you have, you describe all the things, and then you subtract all those things.
Yes. Yes. Cool. Thank you. Like the most complicated part for this, is the shrink, the vertical and horizontal. And so what does that look like? That's why I just plugged it, I just left it in here because I already wanted to account for that. All right,
And then what is,
this, which, these points right here? That is this graph right here. Because so that's what this is right here. I graphed this right here, right? And then from that point on, I could shift it wherever I want. From this, I could shift it. You know how I went from the black to the red because I went left 3. And then I went from the red to the blue because I went up 3. Okay, all right. By the way, guys, this is the difference between algebra 2 and like algebra 1 is I have to throw all these things. Like, I wish I could kind of just go step by step, right? But I have to throw all these things at you at one time. And you guys have to kind of like, oh, okay, you kind of figure it out. This is the difference between algebra 1 and algebra 2. Okay, so whereas like algebra 1, you were okay, let's do quadratic formula. Bam. Like here, I'm throwing 5 things at you. You have to kind of figure out what bam, 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 bam. And this is the math behind it. All right, and so that's why I really like these questions. Okay, yes, Kira.
so the 2 is basically the slope, correct?
Yes, you could think of it that way. You could think of it that way. But again, we don't have a slope because it's an absolute value function. But yes, you could think of it that way. Like if you think of y equals x and then y equals 2x, right? What's the difference, right? You have one doing this and the other one doing this, right? I should just do one's in red and the other one's, this is the 2x right here. All right, cool. Now we gotta move on. We're going to number 3. All right. Oh, dude, period's gonna end in what? 15 minutes. All right, here we go. Let me try to finish. Okay, so, and I hope I have enough minutes on the free Zoom account. All right, y is equal to the cubic function. So let me try to figure this out here. Y equals x horizontal stretch. So that's cubic function is here. Don't copy this down yet. Give me a second. Left 3, left 7, down 1, and then horizontal stretch by 3. So it'll be, okay, so it'll be y equals 1/3 x minus 7 cubed minus 1. This is the cubic function, horizontal stretch by 3, shift left by 7. Left would be plus, and then down 1. Okay, yeah. So that should be it. This is the cubic function right here. Okay. The 1/3 is the horizontal stretch by 3. Remember the horizontal stretch, you're flipping it over, right? And then it's the 1/3 from there. All right. Cool. Letter B is radical function. So y is equal to, let me figure this out. Vertical shrink, you're taking the actual value, reflect over the x-axis, radical, and then right by 3, so it'll be x minus 7, and then down 5, which would be minus 5. So let me rewrite this. Okay. Cool. All right. Number 4. All right, I'm just gonna do one parabola because we gotta get going. Let's do the one that's facing down. All right, put it in vertex form first. So that's what 1, 2, 3. All right, you know what? Let's just count by 2s. 1, 2, and then 1, 2, 3, 4, 5. Let's say the h is 2 and the k is 5. So it's y is equal to a and then x minus 5 squared plus k. I'm sorry, plus 5. Sorry, my bad. Y minus x minus 2, and then sorry, plus k is 5. And so and then we have to find the a. How do we find the a? We by plugging in one of these points. So 1, 2, 3. Let's plug in 0, 3. We're gonna temporarily plug it in for X and Y. So it'll be 3 is equal to A, and then 0 minus 2 squared plus 5. You guys see where I did that? I put the 0, I used any point on that parabola. I plugged it in for X and Y, and I'm trying to solve for A. All right. So what? 3 is equal to, this is -2 squared, that's 4. 4A plus 5. I subtract the 5. And -2 is equal to 4A. We divide by 4. A is equal to -1/2. So our final product is Y is equal to -1/2 X minus 2 squared plus 5. Cool. So let's finish this out. Number 5 real quick. Let's see here. So f of x is equal to x minus 15. The g of x is equal to, this 20% off, it would be 0.8x, right? And then write a function that represents how you would pay with using the $15 coupon first. So I believe that's the point, that's the 0.8. Let me don't write this down. Let me just figure this out. And then x minus 15. This is letter C. And then letter D would be point y is equal to 0.8x minus 15. So this is the $15 off first. This is the 20% off coupon first. But this is the G of, which one's the G of f of x and it was the f, so this is the f of x. So this is the G of f of x, and this is the f of G of x. Okay. And then E is if the shoe costs $100, which coupon should be applied first? So all I have to do is just plug in 100 to both and see what works, which was cheaper. So Y is equal to 0.8, 100 minus 15, and Y is equal to 0.8 times 100 minus 15. So this is what, 85, 85 times 0.8 is what? 68. And then this is 80 minus 15 would be 65, right? So this would, when you would do this one first. You would take the 20% off first and then do the $15 coupon. All right. I need to hurry. Sorry, I forgot to tell you. So this is the original function. What you need to do is, this is like your f of x here. And so you would have the g of x is the inverse function. So remember how you did this? It was y is equal to 2 over 3x minus 6, right? Switch the x and the y, which is x is equal to 2 over 3y minus 6. And then solve for y, right? So add 6 to both sides. So it'll be x plus 6 is equal to 2 over 3y. Divided by 2 over 3. Y is equal to 3 over 2, and then x plus 6. Okay. And then what you need to do is you need to verify that they're inverse functions. So you need to do the f of g of x, and you need to do the g of f of x. Okay, so it is, so let's say this is the g of x here. So you're doing this here. So what you're doing is you're plugging this into this right here. So it would be 2/3. Yeah, 2/3. And then the x would be, you know what, let's multiply this out here. Y is equal to 3/2x plus 18 would be 9. So this would be 3/2x plus 9 minus 6. The distribute, this would be x plus 6 minus 6, will just be x. And then do the same thing here. You're doing y is equal to 3/2. You're plugging in 2/3x minus 6 plus 9. Distribute, it'll be y is equal to x minus 9 plus 9, which is y is equal to x. So you need to show work on this right here, okay? As long as they're both x's, right? Y is equal to x, they are inverses of one another. Okay. I don't know if we're gonna have enough time to get to all this. Number 7. We'll do number 7, and then number 8, I'm thinking I have to kind of just record it on a separate, but pretty much this one should be pretty easy. I'm gonna do this fast. You're just plug in both numbers. So for the first one, there'll be y is equal to 3 times 0 plus 2, right? Y is equal to 2, right? So we have to graph 0, 2, right? And then plug in 3, y is equal to 3 times 3 plus 2, which is 9. 9 plus 2 is 11. So it'd be 3 and 11. 1, 2, 3, and then 1, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're graphing this line right here. And then 4 is pretty easy, right? Because it's a horizontal line from 3 to 7. So from 3, 1, 2, 3, 4, open circle. We're going to 7, 4, 5, 6, 7. And then you could also do this where you could just graph that whole line right there, and then just erase everything. So you go down 1, 2, 3, go up 1, right 2, graph this line right here, right? And then just erase everything that's not between 7 and 10. So I'm thinking 7's right here, and 10, 8, 9, 10. So just erase everything. And make sure you put an open circle here and a closed circle here. Cool. All right. This is being recorded, so you guys will have, and then last problem, let's try to do it. All right. Bob starts out at school, first school at 7 a.m. and drives 10 miles in 15 minutes. So let's just try to go in. Let's see here. Miles would be well, let's go time. And then this is miles. Or should we do miles and then either way? All right. So anyway, 10 miles in 15 minutes. So in 15 minutes, so 5, 10, 15, 20, 25, 30, 35, 40, 45, and then let's just do it in 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. All right, and then so 10 miles in 15 minutes, so 15 or 10, 15 is right here. See, am I going backwards? Oh, whatever. Okay, anyway. This right here. And then he then stops at a restaurant for 30 minutes. So for 30 minutes, so till 45 minutes, he's at a restaurant. Right? And then he drives faster, so 20 minutes. In 20 minutes covers 18 miles. So from here, so at the 65-minute mark, he covers 18 more miles, so that'd be a 28-mile mark. So 28 is like right here. And that's pretty much it, okay? And draw a graph representing what occurred, and then write out each of these equations. So the equation would be y equals, the slope would be rise over 10 over 15, so it'd be 2 over 3x between 5 and 15. Y would equal 10 between 15 and 45. And y would equal, right, go ahead, you guys could go if you need to, but you go up 5 over 1. That'll be at x minus, I have to find the, but between 45 and 65. We'll talk. Yeah, you're able to sign this, one, please. Yep. I know. I got out of it with Saved by the Bell. All right, what am I Zoom?
I'll make sure you don't.